In earlier session, dear students, in earlier session, we were discussing about condition for aromaticity. So that is Huckel's rule. We are discussing about the Huckel's rule 4n plus 2 by electron. So condition for aromaticity must be planar and cyclic conjugated system. It should be planar as well as cyclic conjugated system. And the complete delocalization of pi electrons in the ring. In the ring, the delocalization of pi electron means completely, if we take the cyclic compound, the electron should be delocalized completely. And when the presence of 4n plus 2 pi electron, where n is an integer from 0 to 1, 1, 2, 3, 4, etc. So 4 plus 2, that is equal to 6 electron. 6 pi electron, that is equal to 3 pair. 3 pair, 3, it begins from the alternate 3 bonds. As well as in the case of 4 into 1, sorry, 4 into 2 plus 2, 8 plus 2, that is equal to 10 electron. 10 means the 5 bonds. So 3 bond or 5 bonds or 4 into 3 plus 2. So that is 12 plus 2. 14 electrons is nothing but the 7, the 5 bonds. So these number of bonds means it follows Huckel's rule 4n plus 2 pi electron. So this is a condition for aromaticity. So in that also we'll be having few of the compound will be having means aroma characteristic fragrance. In that the few will be having a benzene ring, minimum benzene ring, and few of the compounds are not having a benzene ring, but they are conjugated system show aromaticity. Will be having 4n plus 2 pi electrons. So those are be divided as conjugated and non-benzenoid and non-benzenoid benzenoid compounds and non-benzenoid compounds. So first one, benzenoid aromatic compound. This also we were discussing in earlier, that is benzene, toluene, naphthalene. You can see that we'll be following 4n plus 2 electrons. 4n plus 2 electrons here, 2 plus 2 plus 2, 6 electron. So here 4n plus 2 electron here, 2, 4, and 5. Okay, that is a number of pi electrons. This will be following n is equal to 1 pi electron is 6. N is equal to 3 pi electrons is 14. So 14, so 7 bonded system, 7 pi electrons, 7 pair of the pi electrons. These are in benzenoid aromatic compound means will be consisting a benzene ring. The aromatic compound will be consisting a benzene ring. And few of the compound are not having the benzene ring. Those are we call as non-benzenoid aromatic compound. Apart from the benzene, means six-member ring. So you can notice here in the pyridine. So in this pyridine, we'll be having the 5 carbon and 1 nitrogen. 5 carbon and nitrogen, or pyrrole here also. 1, 2, 3, 4. 4 carbon and nitrogen, nitrogen and hydrogen. In furan, the same 5 carbon and one of the carbon replaced by oxygen. Here, one of the carbon replaced by sulfur in thiophene. As well as you can notice it cyclopentadienyl. So pentadienyl. This is cyclopentane. That is ene, diene, double bond. Okay, alternate double bond. That is an anion. Cyclopentadienyl anion, negative charge. Similarly, cyclohepta trinyl, 3 compounds, 3 alternate double bond, trinyl cation, so positive charge. So these will be the follows the same 4n plus 2 by electron. But what happens in all these cases? These are not having benzene ring. Doesn't consist of benzene ring. So these are an example for non-benzenoid aromatic compounds. So pyridine, so need to remember pyridine. So benzene in that as like a benzene, one of the carbon replaced by nitrogen. That is 6 member. So 5 carbon and 1 nitrogen. In the case of the pyrrole, 5 member, so total 5 member, 1, 1, 2, 3, 4. So out of 5, 1 carbon is replaced by nitrogen. So C4 and 1 nitrogen is pyrrole. Here also 1, 2, 3, 4. 4 carbon plus 1 oxygen. One of the carbon replaced by nitrogen pyrrole, oxygen furan, and sulfur thiophene. So this is dinyl, 5 carbon. So cyclopentane in the double bond, it's pentene and diphene, dienyl group. dienyl group. So I said by nomenclature we studied this dienyl. So double bonded compounds is represented as dienyl compound and anion. Okay, so negative charge. Here in the positive charge, cycloheptatrienol cation. This will be the aromatic compound, but doesn't consist the benzene ring, non-benzenoid aromatic compound. And few of the compound are called anti-aromatic compound. What is the meaning of an anti-aromatic compound? Will be having 4n rule. Will not follows the 4n plus 2 pi electron, not follows in Huckel's rule. So we'll be having the 4n rule. These are the planar conjugated cyclic compound having 4n pi electron. So this also will be having in a conjugated system. Sure, no? So alternate, it can shift here, it can shift here. We'll be having an alternator. And here, so keep on replacing here. This electron can shift here, this can shift here, this can keep on moving the conjugated pi electron system. But here, this is 4n pi electron. 4n pi electron. So here n is equal to 1, 2, 3. That is a carbon number. So 4 into 1, that is 4 into 1, that is equal to 4. 4 here cyclopentadiene. So 4 electron, 4 into 2, that is 6. 6, 2, 4, 6. 2, 4, 6. And I know the pair of electron negative charge is nothing but this also follows the conjugated system. Similarly, 1 and 2. 4. Here what happened? Only one, the pair of electron. This is an anion. So if it will shift here, this pair of electron shift here, we'll be having an alternate bond. So this is also means few of the compound here will be, so this is double bond, means that this double bond means 4n rule. This will be following the 4n rule. These are the compound, means conjugated cyclic compound will be having an alternate double bond, but will not follows Huckel's rule 4n plus 2 by electron. These are we call as anti-aromatic compound, and anti-aromatic compound will follows 4n pi electron. So example for anti-aromatic compounds are cyclobutadiene, cycloheptatrienol carbene ion, negative charge, carbene ion, cyclopropenyl carbene ion, propenyl negative charge, carbene ion, cyclopentadienyl carbocation, positive charge, and cyclooctatetraene, 1, 2, 3, 4. So tetraene, 4, the double bond, alternate double bond. These are the compound will not follows Huckel's rule. Those are we call, and this will be having conjugated double bond. These are we call as anti-aromatic compound, which follows 4n rule or 4n pi electron. Okay, this is about the structure. So next we'll study about physical properties of benzene. So what are the physical properties? Benzene is an aromatic hydrocarbon or the non-polar molecule and usually colorless liquids and solids. So aromatic compound, especially benzene or benzene derivative, these are maybe benzene or non-benzenoid. So these are the hydrocarbon or non-polar molecule. Non-polar molecules means electronegativity difference is less, non-polar molecule, and usually colorless liquids are solids. The physical property, first physical property or the first point. As well as these are having characteristic smell, characteristics aroma. Example, naphthalene. Will be using naphthalene ball. Naphthalene ball, especially will use in toilets or in preservation of clothes. So we'll be using the small white and other different color balls, naphthalene balls. Okay, and will be having a unique smell, and it also used as why moth repellent property. Why this will be used? Because of moth repellent property. Okay, naphthalene, the characteristic aroma. This is an example on naphthalene as an example. Fused benzene ring, two benzene ring are fused together. Okay, two benzene ring are fused together, which gives naphthalene. Okay, next, similarly, which gives in sooty flame. Okay, which burns with sooty flame, and these are immersible with water. So which is not soluble in water. These organic means aromatic hydrocarbons are insoluble in water. Aromatic hydrocarbons are immiscible with water but readily miscible with organic solvents. Organic solvent, non-polar molecule, the miscible. And the burn with sooty flame. Carbon content, no carbon rich, they always burns with a sooty flame. Okay, sooty flame, the char, black color flame, that is what we call as sooty flame. Okay, next, these are the physical property. Which are the physical property? Here, need to remember, aromatic hydrocarbons are non-polar molecule, usually colorless liquids or solids. And these compounds are having a characteristic smell, aroma. Example, naphthalene will be used as moth repellent balls. Next, aromatic hydrocarbons are immiscible with water, but readily miscible with organic solvent. Miscible, mixing. Okay, immiscible, doesn't mix properly, immiscible, and burns with sooty flame. Okay, dark black color. So what is called as sooty flame. Next, these are the physical property. Next, chemical properties of aromatic hydrocarbon. In chemical property, we need to study about how these are reacts, means which type of reactions they undergo, whether addition or substitution or elimination, what type of reaction is favored, and why these are favored in aromatic hydrocarbon. First one, so chemical property, first, aromatic hydrocarbon are arenes. Aromatic hydrocarbons also called as arenes in the beginning itself, I said. So arenes are characterized by electrophilic substitution reaction. Electrophilic substitution reaction means undergoes an electrolytic substitution reaction, electrophilic substitution reaction, and the special condition, that to normal condition, that's not in a normal condition, and special condition can also undergo addition and oxidation reaction. So electrophilic substitution reaction, because of the conjugated pi electron system. So these are the benzenoid compound. Aromatic hydrocarbons are stable. Aromatic hydrocarbons are stable because we'll be having conjugated pi system. Due to conjugated pi system, this will be stabilized by resonance effect. If they are stabilized by resonance effect, it's unreactive. Normally, it will not react. So what happened? So electrophilic substitution, because identical hydrogens are there, so we can get the substitution reaction, electrophilic substitution. But and under a special condition, that is normal, not a normal, and under special condition, they undergo addition and as well as oxidation reaction also. So based on the condition or atmosphere of the reaction, they undergo, then show different types of reaction. So we'll be studying in detail. Okay, first electrophilic substitution reaction for aromatic hydrocarbon, especially benzene. Electrophilic substitution reaction of benzene, what it is? Benzene undergo electrophilic substitution reaction because it contains electron-rich center in the form of pi electron. Which are the compound undergo electrophilic substitution reaction? These electrophile needs to attack on electron-rich group. Electron-rich group. Which are the electron-rich group? Will be having conjugated pi system. This is an electron-rich group. And the common electrophilic substitution reaction of this arenes are, which type of electrophilic substitution can takes place? That is nitration, halogenation, sulfonation, and Friedel-Crafts alkylation and acylation. Friedel-Crafts alkylation and acylation. So what happened? In which, in this all this reaction, attacking reagent in the electrophile E plus attacks on the electron rich center. Electron rich center means pi electron system. On the pi electron system, and the further reaction will take place. So benzene undergo electrophilic substitution. Why? Because will be consisting, benzene is an electron rich because of the pi electron system. And the common electrophilic substitution reactions are nitration, halogenation, sulfonation, Friedel-Crafts alkylation. So nitration, NO2 group, halogenation, X group, sulfonation, SO3 group. And Friedel-Crafts alkylations are acylations, methyl group, CH3CO, methyl group, acyl, COCl, or the CH3 alkyl group. So Friedel-Crafts alkylation reaction or acylation reaction. In this reaction, which attacking reagent is an electrophile. So what we'll be taking? The E plus electron deficient group. So we'll say that, so what it is in positive charged electrophiles attacks on electron rich group. So we'll see, we'll be studying one by one. First is nitration. What it is nitration? When benzene is heated with mixture of concentrated nitric acid and concentrated sulfuric acid. So nitric acid is an HNO3, okay, and sulfuric acid, that is H2SO4. A nitro group is introduced into the benzene ring. A nitro group, NO2 group, is introduced. NO2 group is introduced when we use H2SO4 and HNO3. Okay, H2SO4 we can write, this is H2SO4, and HNO3, HNO3. The sulfuric acid, first one, and second one is nitric acid. In H2SO4, we can write 4 of oxygen, I split, and I can write like this, no? HO3 and SOH. So total H2, 2 hydrogen, SO4. H2SO4 I divided as HO3SOH. Okay, and this sulfur oxygen bonding, 1 hydrogen. Next, HNO3 I'll write as HO oxygen, and we'll be having the nitrogen NO2. Oxygen, no? HNO2 and O2, nitrogen and oxygen. So oxygen is an electron rich group on this. Okay, when this pair of electron donates to or binds with this oxygen, and pair of electron will be shift to oxygen to sulfur, means hydrogen oxygen bond, the electron shifts on the oxygen, this oxygen. Okay, and then what happened? Not sulfur, this oxygen from here to here. So what happened? This NO2, this will be combined together, will be forming this reversible reaction HO, and this will be hydrogen attacks to this, and the rest of the group is NO2, okay, will be having an electron, then HSO4 minus. This is HSO4, this whole negative charge, no? SO3 and O, HSO4 minus, left behind with hydrogen. Hydrogen attaches to this group, it becomes HHONO2, HOO positive charge. Are you getting? This is reversible reaction. This is protonated nitric acid. This is protonated nitric acid. In protonated nitric acid, nitrogen pair of electron donates to oxygen. If pair of electron donates to oxygen, because I'll be having positive charge, deficiency of an electron, so it forms H3O plus hydrogen, oxygen, hydrogen. H3O plus or H2O, 2 of hydrogen, sorry, 2 of hydrogen will be forming H2O. H2O water. If water will be separated from this, what will be the left behind? NO2. NO2 electron donates, then will be forming NO2 plus. NO2 plus nitronium ion. NO2 plus is nitronium ion. This is a mechanism how it will be forms. The nitro group is introduced on benzene ring. This NO2 group attacks in benzene, then the reaction, substitution, hydrogen is replaced by NO2, will be getting nitrobenzene. So we'll see this when mixture of concentrated nitric acid HNO3 and concentrated sulfuric acid H2SO4 sulfuric acid. Okay, these are mixed together and NO2 group, NO2 will form NO2 plus nitronium ion. This nitronium ion attacks on benzene ring, will give nitrobenzene. This is a reaction. Okay, so you can notice, you can see on the screen. Okay, this is benzene, say 6H6. So mixture of HNO3 and H2SO4, that is 3 23 to 333 Kelvin. So together HNO3 and H2SO4 gives an NO2 plus nitronium ion attacks on benzene ring. So replaced by hydrogen, which gives an NO2. Say 6H5NO2. This is called nitrobenzene. Along with formation of water, this hydrogen and the rest means NO2 group, no, they will be forming NO2, nitronium ion, and H2O will be hydrogen will be eliminated from that, will be forming H2. Okay, this is what you need to remember. Just understand mechanism, and if nitration, what do you need to write? When benzene, what do you need to write? They asked to write nitration, any one of the reaction. So usually for the theory they used to ask, but in a competitive field you need to know all the reactions and how they are combining with each other. So nitration, when benzene is heated with mixture of the concentrated nitric acid and concentrated sulfuric acid, concentrated HNO3 CONC, I'll write concentrated HNO3 plus concentrated H2SO4. This together we know as nitrating mixture. Within a bracket, I have this nitrating mixture. And NO2 group, nitro group is introduced into benzene ring. So this is a reaction. So benzene plus concentrated HNO3 H2SO4 gives rise to nitrobenzene. Okay. This is the first one, which type of reaction it is? Electrophilic substitution reaction of benzene. Next, halogenation. Name itself indicates halogen, group 17. Group 17, arenes are benzenes. Example, benzene, arene. Okay, benzene react with halogen in presence of the Lewis acid. Lewis acid, what we are using, the anhydrous aluminum chloride, Lewis acid and Lewis base. So Lewis acid, anhydrous aluminum chloride, or ferric chloride, or iron bromide, or aluminum chloride, gives an haloarene. So halogenation reaction, benzene react with treat with the group 17 elements in presence of anhydrous aluminum chloride. Out of this, we'll be using more widely used anhydrous aluminum chloride or ferric chloride. Anhydrous aluminum chloride or ferric chloride. So gives chlorobenzene. Chlorobenzene and the hydrogen replace hydrogen with hydrochloric acid. So halogenation, benzene or aromatic hydrocarbon treat with chlorine in presence of anhydrous aluminum chloride will be getting chlorobenzene. Okay, next reaction. In next year we'll be studying in detail. Actually, this not next year. Here only you need to understand the reactions. Just an electrophilic substitution reaction. The mechanism how it forms, that mechanism is different. Removal of proton is how the electron gets attached, how uranium ions are formed, and those are the mechanisms. So halogenation, that's benzene or aromatic hydrocarbon treat with chlorine in presence of anhydrous aluminum chloride gives chlorobenzene. Okay, next, sulfonation. So in nitration, name itself, nitro group. Halogenation, halo group is substituted, means electrophilic substitution reaction. In sulfonation means sulfo group. Sulfo group is sulfonic acid. Sulfur group is sulfonic acid. Sulfonic acid is keep on replacing. SO3H is called sulfonic acid. The replacement of hydrogen atom by sulfonic acid group in benzene ring is called sulfonation, and it is carried out by heating the benzene with fuming sulfuric acid. Fuming sulfuric acid is called oleum, H2S2O7. H2S2O7. You'll be studying in the preparation of sulfuric acid. In the preparation of sulfuric acid, what we get, the product is oleum. Oleum is H2S2O7. H2S2O7 is called oleum. Okay. From this heating with the oleum, so benzene is C6H6. So this benzene treat with the concentrated fuming sulfuric acid. Fuming sulfuric acid is H2S2O7. This can be written as H2SO4 and remaining is SO3. So total seven of oxygen, sulfur and sulfur, two hydrogen. Okay, H2SO4 and SO3. SO3 group will attach on benzene. So upon heating will give C6H5SO3H. SO3H with the formation of water. So this H2SO3, so C6H5SO3H is called benzene sulfonic acid. Benzene sulfonic acid. Benzene sulfonic acid. Are you getting? So aromatic hydrocarbon, benzene treated with concentrated oleum means sulfuric acid means preparation of sulfuric acid. How if you studied the preparation of sulfuric acid, so we'll be having few important process: manufacturing of sulfuric acid or preparation of sulfuric acid, nitric acid, and the manufacturing of ammonia. Those are important. We'll be studying in next year. Okay, that is manufacturing of sulfuric acid by contact process. In that contact process, what the final product we are getting is H2S2O7. This H2S2O7 is called oleum. Okay, so equation: benzene plus H2S2O7 upon heating oleum, which gives benzene sulfonic acid, that is called sulfonation. Clear? Next. First one is nitration, next is halogenation, next is sulfonation, next Friedel-Crafts alkylation or acylation. So what is Friedel-Crafts? Friedel-Crafts will be using Friedel catalyst. Why it is called as a Friedel-Crafts reaction? Because we'll be using Friedel catalyst. What is Friedel catalyst? Anhydrous aluminum chloride. Anhydrous AlCl3. Anhydrous aluminum chloride is called Friedel catalyst. Hence, this reaction is called Friedel-Crafts reaction. So, for the Friedel-Crafts reaction, when benzene is treated with alkyl halide, so benzene, this, right? So benzene. This benzene treated with RX alkyl halide like methyl chloride or ethyl chloride, ethyl bromide, or etc. in presence of anhydrous aluminum chloride AlCl. So which gives CH3Cl here or Cl, CH3Cl or CH3Br. This R group CH3 example R and X is Br. So what happened? This R group will be substitute in the place of hydrogen, and hydrogen combines with Br, it will be forming HBr, will be getting C6H5. Just a minute. So we'll be getting C6H5 CH3. So is nothing but, if you use alkyl benzene, we'll be getting alkyl benzene R group, or a CH3. If it is C6H5 CH3, then it is called toluene. Or benzene treat with any ethyl benzene. If you treat with the ethyl group, ethyl bromide, then you'll be getting C6H5. C6H5 means this hydrogen is replaced with the C2H5 group. C2H5 group attaches, means R group attaches to replaced hydrogen. Here hydrogen, it will be replaced. We'll be getting C6H5, C2H5. C6H5, C2H5 is called ethyl benzene. So what is Friedel-Crafts alkylation reaction? When benzene is treated with alkyl halide in presence of anhydrous aluminum chloride, alkyl benzene is formed, or C6H5 alkyl benzene is formed. Anhydrous aluminum chloride is known as Friedel catalyst. So benzene C6H5. Here you can see, no, these two are the example. Here benzene C6H6 plus CH3Cl and replaced with hydrogen, will be getting C6H5CH3 is called toluene with the formation of hydrochloric acid. Similarly, C2H5Cl, ethyl chloride, this R group C2H5 replaced by hydrogen will be getting C6H5C2H5 is called ethyl benzene with the formation of hydrochloric acid. Okay, this is Friedel-Crafts reaction, Friedel-Crafts alkylation reaction. Similarly, this we have another reaction is Friedel-Crafts acylation reaction. Acylation reaction because of acyl halide or CO or CO group, COCl acyl chloride. Okay, COCl acyl chloride, COCH3 acyl methyl. Okay, will be getting. So this needs to be means to need to get the acyl halide. Okay, acyl halide. What we need to do? So this has to be treated with benzene, has to be treated with anhydrides and hydride, especially acetic anhydride. So anhydride removal of water, CH3COOH acetic acid. So here I'll write one more molecule, CH3COOH. In that we remove water content, H2O, H and OH, H2O. What will be the left behind? CH3 CO twice and O, right? This can be written as CH3COO, CH3CO, CH3CO combined with an oxygen O, CH3COO and CH3COO or CH3COO twice O is called acetic anhydride. If we treat an acetic anhydride, COCH3 group, CH3CO group replaces hydrogen and another CH3CO and O combines with hydrogen. It here below I'll change the color. Here CH3CO. This is acyl part. This acyl part attached to benzene. So we'll be getting acyl benzene, especially methyl benzene or ethyl benzene, acyl, any acyl benzene. So what happened here? Rest of the thing CH3COO and replace the hydrogen combines together, it will be forming CH3COOH. Okay, that is acid. Okay, so example, we can see example here. First one. So when the reaction of benzene with acyl halide or acid anhydride, acyl halide RCOCl, RCOCl or no, acid anhydride. Example, we have taken CH3COOH, acetic anhydride. In presence of Lewis acid like aluminum chloride, anhydrous aluminum chloride is acyl benzene. So this is benzene, CH3CO twice O, acetic anhydride, and the CH3COO group, acid anhydride. And in presence of anhydride aluminum chloride gives acyl benzene, C6H5COCH3, and with the formation of CH3COOH. Similarly, this will be treated. We said that acetic anhydride. If acetic anhydride replaced with acyl, this become CH3COCl. Okay, so this is not, this again same equation. So here, this will be, if it is instead of anhydride, this will be replaced with, I'll change the color. So replaced with CH3COCl. CH3COCl, acyl chloride. Okay, acyl chloride. Then what happened? There is no extra product. Same, we'll be getting COCH3 group attaches to this, and the Cl group combines with hydrogen, will be getting HCl, hydrochloric acid. I said that when benzene is reacted with alkyl halide, first equation, or acidic anhydride, acyl halide is here. Second equation, and the acetic anhydride is the first equation. We'll be getting acyl, means we'll be getting, so benzene, acyl benzene. This is Friedel-Crafts acylation, alkylation and acylation. For all these group, for what are the reaction we studied, and these will be having mechanism. So we need to know the mechanism, how reaction will take place, how reaction will take place. So we need to study the mechanism of the electrophilic substitution reaction. In this electrophilic substitution reaction, what we noticed, simply we have written this benzene for CH3 group. I'll take the blank screen. So here, what we studied, simply we have taken benzene, and this benzene replaced with any of the halogen, example halogenation, like chlorine. Chlorine replaces this, and Cl2 will be forming C6H5Cl. So this is what we studied, simple reaction. This reaction will be having mechanism. Which are the mechanism? First, electrophile need to generation of electrophile. Second, after the generation of an electrophile should forms an intermediate. That intermediate means should forms an cation, carbocation. To that formed, carbon should have the carbocation, should intermediate will be getting. After the formation of intermediate, hydrogen should remove from that removal of proton from the intermediate. So three steps. Which are the three steps? First one is generation of electrophile. Second one is formation of carbocation or intermediate carbocation. Carbon should have positive charge, carbocation. And third one, removal of proton from carbocation. Removal of proton, H plus, okay, from carbocation or intermediate. These are the three steps. So we'll see step by step how the electrophile is generated, how generation of electrophile will be takes place. Just with the taking of any one example, how ions will be forming, how it will be attacked. Okay. First one, mechanism of electrophilic substitution reaction. Electrophilic substitution reaction proceed through the following step: generation of electrophile, formation of carbocation intermediate, and removal of proton from the carbocation intermediate. First, generation of electrophile. During halogenation or chlorination, alkylation, acylation of benzene, anhydrous aluminum chloride being being a Lewis acid helps in generation of electrophile, formation of Cl plus R plus RCO plus. So this is acyl ion, is called asylum ion. So these positive charge combine with the attacking reagent, and which is a product. In that, the first one, electrophile, generation of electrophile. We'll see an example. Cl2. When we use anhydrous aluminum chloride or AlCl3. In that AlCl3, Cl2 group, Cl and Cl. Cl2 is between Cl and Cl, the bond between Cl and Cl. So Cl combines with aluminum chloride, AlCl3, will be forming AlCl4. AlCl4, but it will be exist as AlCl3 only. 4 is an extra, no, AlCl4, extra ion, negative charge, anion, AlCl4 anion. So this will be forming, this is not homolytic or heterolytic. So this is heterolytic separation, heterolytic, homolytic and heterolytic, or homolysis and